the space has to be managed amicably, and then only the grid will become smart. So in the smart grid infrastructure, if you think about what are the main elements of this grid infrastructure, you can think about there is an advanced metering infrastructure. So these are the meters installed at various places and communicating amongst themselves, so that we know the estimates of energy consumption at various points. And majority of these smart meters, of course, are in the houses, but as I told you, in the even distribution network as well, we will have bigger grid meters and things like that. So they will be installed and they will be communicating, and you will be able to monitor them, the consumption, and abnormalities can be managed. And of course, the patterns of usage can also be easily monitored from this metering. So we call this whole of thing as an advanced metering infrastructure. And along with this comes a whole of a data management system which runs at a back end, which collects all sort of data, and all that data analytics that we talk of these days. Everybody knows about the importance of that. All that data analytics goes on behind in the back end system. And we call that as MDS, metering data system. Electric vehicle, I already talked about. So both in-home and distributed charging infrastructure, anywhere in the cities you'll find. So distributed automation systems like communication sensors, equipment for distribution of the energy. There have to be systems that manage this whole of the distribution. And like, for example, these days, many a times it is manual. So particular consumer segment must be removed, and load must be less. I mean, the supply must be less. So all this automation with time can be automated with the proper systems that are there using the software. And you can carry out all that optimization and management. Substation automation, as I told you, not only distribute and transfer upwards. If you talk of, there are substations, and there are further substations which are of the higher energy domain. So all those things are connected today. If you go to a substation, you'll see how much of communication and measurements are happening, and how they're integrated into the whole of the grid. So there's a lot of modernization that has happened to the substations. And transmission system upgrades, we have many, enablement of this measurements of various parameters of this whole of transmission system, and gradual regular communication of that happens gradually. So smart grid is a very big and complex system, and these are some of the main elements of this which have to be then made all smart. So I will not go one by one, but I think just for the completeness sake, I think I'm also coming close to my time. So Scada Systems basically do all that. So these are the Scada systems, nothing but is the computer systems which get all this communication and monitor and control all the operations across the grid. And these are all communicated over IP networks. And of course, you have got all the relevant parameters, and these parameters are summarized upwards from endpoints to get a broader view, what we call as a dashboards at various levels. So you can only monitor the substations and see how substations are behaving, or you can go deep into it and all distribution transformers you can monitor, or even, of course, there is a big issue of privacy here, but even how an individual person is energy consumption during the 24-hour, during the month, all that is possible. And some places, of course, due to privacy, people are not allowing even the smart meters. So, but this in other way also helps you to optimize your energy consumption. So, but anyway, these are all the questions that are there always with your technology. So distribution and transmission grid aspects of the grid, I have mentioned some of them here, but they may be more, of interest to people who are probably working in the energy systems. But just for the sake of it, that what are the functionalities of this transmission and distribution subsystems of the grid that are there. So there are grid meters, that are installed, as I mentioned, and they're all talking to the Scada system, which is monitoring this. End users, of course, I just mentioned, they have got the homes, buildings, commercial buildings, industries, and AMI, as I mentioned, which has got various meters, which are these days smart meters, and they are continuously, you can just set the meter at, say, please monitor my energy consumption every hour or every 30 minutes. So all those things easily can be set, and the data actually based on that sampling rate goes to the backend or the energy supplier. So you've got a communication subsystem. So if you got, think of a multi-story buildings, so there are home area networks that are actually communicating with each other, and you have got the in-home displays in the devices, and there are appliances nowadays in houses. You are getting always the smart appliances gradually coming up. So I will not go into detail. The smart meters are very, very intelligent devices these days, and there are various type of monitoring these devices can do. Okay, what sort of load was there, when there was a any particular device use. So all those things are logged apart from the various aspects that we have talked of, auto calibration, inbuilt self-diagnostics. Okay, suppose you go on a leave, you can always put that meter off, so it will not supply any energy. So there's a local energy, local memory storage here available up to whatever time. Of course, there is not much, but up to a month can be easily done. And you can also log or flag various types of events that happen on the. So smart meter is a very, very powerful device. Hello? Another 5 minutes and I'll be closing. Yes. The desired behavior of smart meter is record the consumption with the best possible accuracy. So this is one of the smart devices that we can think of and how it behaves. So behavioral aspects of this, you can see that how it is smart. So it records the consumption, reports energy consumption at intervals, elicit behavior of consumption patterns. Like you can say that, okay, most of the time in the nights only your energy consumption is more. Correlate consumption rates with appliances in house. So you can say your fridge is actually taking more than the expected energy. So you must replace the fridge, or govern consumption by set limits. Also use a prepayment meter that can happen. Raise alert alarms for tempers. So suppose somewhere some shortage happens, your machine is not working due to some fault. So all those things will be logged and alarms will be raised. Remotely readable and controllable. So from yourself, you can switch off your fridge, you can start your washing machine and so on and so forth. So all those things will be possible. And improved revenue collection. Automated that happens, as I told you, every half an hour the meter consumption goes to the back end, and automatically the even the differential tariffs that I mentioned, you may have different charges in the per unit in the daytime, and the evening night time there may be different charges. So automatically, I'm sure you understand this is the simplest thing to do. Easily you can get the revenue based on the consumption. So for the communication system, very important area is you can have the various type of protocols. We based on the wired and wireless. DLMS is a very important protocol these days in use. Then there's a metering bus, Z-Wave, Bluetooth, Zigbee, Wi-Fi, GSM, GPRS, and you will talk of 4G and 5G as well now gradually, and mesh radio. So these are some of the communication protocols very popular on home area network. These are not for the grid, and some of the smart meters, and you can have a look. This belong to my previous company where I worked. So there are some devices which are put in your home and connected to the meter. So you can see here all the consumption that is going on. So of course the rest is smart appliances. You have got smart air conditioners, smart fridges, and there are all type of devices now. These are all communicating, and they are easily monitored on the network. So I think most of the things you are now yourself in India also, we are seeing those things happening. So they help in demand response management and automation of energy consumption. So these are some of the things you can see in a typical smart home, and of course this is drawn from Western countries. So you have smart thermostats, so it's a heating of the house, and air conditioning, smart energy meter, gas water meters, demand control you can do here, smart appliances, smart lighting, and of course your e-vehicle charging also will gradually come in. So this is a typical graph that is generated from the data that is monitored from a smart meter, and this sort of thing one can also, a user can also get access to. But these are the data that is actually available at the back end. The energy distributor, they have got the details of this energy consumption of individuals, and that's where actually we are talking of the privacy of the users. Very big concern, particularly in the US and especially the state of California. So they have not really been very encouraging users. People, not all are allowing the smart meters to be installed in the houses. So, but it gives you insight into how your daily living is, what time you are at home, so that based on your energy consumption, what are your typical activities, when you wash your clothes, and blah blah. So many things can be derived from all of this data that is available. So very important, but of course I'm unable to misuse if there are some people who make misuse of that. But so this is another way of day-wise consumption of your home that you can easily monitor. So it's a typical. So you can see how powerful have become these devices if they are embedded with the smart features and including communication. So just wanted to give you some thoughts about what is a smart system, and an example that we try to give using a smart transmitter. Then smart grid is a bigger system and its components which themselves are smart. So this was a brief introduction and with some examples, and I'm sure most of you are able to understand. Many of the people who are in computing domain, for them of course it must have been a very simple thought, but I'm sure to others it has been informative. So that was all from my side. If there are some questions, I'll be happy to take.
Thank you, sir. Any questions? Okay.
Of course, you are most welcome. I think I removed my email, but you have my email and you can get any questions if people have, so that we can, I can try to answer them.
Okay, sure, sure. So now we are going to start our technical section second. In this technical section, we are going to present 6 papers, and we have 2 session chair members. One is Dr. Pushpinder Singh Khatija. He has completed his PhD and post-graduation from Maulana Azad National Institute of Technology, NIT Bhopal. He has a proven record of teaching in software industry for last 29 years. His previous experience shows that he had an opportunity to work on variety of projects. He is presently working as a senior associate professor in School of Computing Science Engineering at prestigious VIT Bhopal campus. He has presented more than 50 papers at both national and international level conference. Recently, he has completed certification of Certified Ethical Hacker of EC Council and Analyst Security Operations, NASCOM. He was appointed as an expert at Smart India Hackathon 2017 and 2020, organized by MHRD AICTE New Delhi. Pushpinder Singh, sir.
Thank you very much, ma'am, for the introduction.
Thank you, sir.
Thank you, ma'am.
Our next session chair is Dr. Nafisuddin Khan. He has received his Bachelor of Engineering degree in Electronics and Telecommunication from Amravati University at 2003. He did his MTech in software systems from Samrat Ashok Technological University, Vidisha, Bhopal. He has completed his PhD from ABV, Indian Institute of Information Technology and Management, Gwalior. Dr. Nafees has also worked as an assistant professor in JP University of Engineering and Technology. He is working as an assistant professor in JP University of Information Technology, Solan. He is guiding 2 PhD scholars in the area of digital image processing and has supervised 3 MTech theses in the different areas of image processing. His areas of expertise is digital signal processing, digital image enhancement and denoising, fuzzy-based applications in image processing, and fuzzy optimization and decision making. Dr. Nafisuddin Khan.
Yeah, thank you, ma'am. Thank you. Good afternoon to everyone.
Sir, today you are the session chair, so 10 minutes you can give. Okay, it's to you 10 minutes to every paper presenter. Okay, and question answer round you can only manage. So on the line, I will request our first paper presenter, Miss Mitul Biswas and Swapan Dev Varman.
Thank you, ma'am.
Are you there?
Yes, sir. Yes, ma'am.
Okay, just please turn on your camera, please. Okay, okay, sir. So he is presenting his paper on a new approach for credit card fraud detection using machine learning. Over to you, sir.
Ma'am, may I start?
Yeah, you can start, sir.
Thank you. So, good afternoon, everyone. My name is Mitul Biswas, and I am
Mr. Biswas, sir, your voice is not that much audible. Please adjust your mic.
Now it is audible?
Yeah, yes, sir. Now it's audible.
Okay. Good afternoon, everyone. My name
now
is
Mitul. It's not audible.
Now it is audible?
No, sir. It's audible, but very noisy. It's noisy.
Now it is audible, ma'am?
Yeah, okay.
Okay, good afternoon, everyone. My name is Mitul Biswas, and I am from National Institute of Technology, Agartala. I'm feeling very happy and glad to present my research in the International Conference on Emerging Trends and Artificial Intelligence and Smart Systems, organized by TEEETAS-2022. Today, I'm going to present my research on a new approach for credit card fraud detection using machine learning. I have divided my presentation into the following subdivision, that is introduction, objectives, literature review, research methodology, results, conclusion, and references. So coming to introduction, the financial industry is growing at a rapid pace. As a result, banking online transactions on the rise as the government promotes digital India. Debit or credit cards have been used for the measure of the financial transactions. As a result, the fraud associated with it also on the rise. However, our current machine learning approaches is unable to correctly detect fraudulent transactions since present fraud detection machine learning algorithms are taught and then evaluated on extremely unbalanced data sets, reducing their performance in real-life circumstances. So coming to the objectives. So what is fraud detection? Fraud detection is a collection of produces an analysis that helps firms discover the prevent unlawful financial transactions. This can involve things like credit card fraud detection, identity theft, cyber hacking, insurance fraud, among other things. So my objective is to making an efficient approach for finding credit card frauds using machine learning techniques. So coming to literature surveys, in this literature survey, Suresh Kumar and other authors have developed a system for detecting fraudulent transactions, determining their correctness. The suggested system employed random forest algorithm and logistic regression. and other algorithms also. This technique utilizes decision trees to classify data set into based on supervised learning. And in this paper, authors have done a comparative study where the performance of the Nav Based Classifier and logistics on high-risk good credit card fraud detection data is investigated. And coming to the next, there is a lot of work in going this field. Like in this paper, we can see ASHA is applying support vector machine and other machine learning algorithms to uncover credit card fraud, as well as machine learning and deep learning techniques to locate non-fraudulent transactions. These are few of the literature surveys that I have gone through for making my research. So what is my methodology? Machine learning algorithm which is used for detecting and fraudulent work into two phases. One in training or learning phase, one is testing phase. During training phase, we have to provide a data set based on which systems learns itself on and take decision for future. But in particular data set related to credit card fraud detection is highly imbalanced, which affects the performance of the algorithm. So coming to my research methodology, my approach, I want to convert the imbalanced data set available in the internet into balanced data set by using existing algorithm. In this case, I am using SMOTE. The SMOTE is synthetic minority oversampling technique. A problem with imbalance classification is that where too few examples of minority classes for a model to effectively learn the decision boundary. One way to solve the problem is to oversample with examples the minority classes. This can be achieved by simply duplicating examples from minority class in the training dataset prior to fitting a model. This can balance the class distribution but does not prove any additional information to the model. An improvement on duplicating examples from the minority class is to synthesize new examples from minority class. This is a type of data augmentation for tabular data, and that can be very effective. And then coming to the second step, we have to measure the performance of the existing algorithm based on the converted balanced data set. Then in start step, we have to compare the performance of every algorithm and propose a solution which is best in every scenario. Then coming to the fourth proposal of a new algorithm based on the algorithm selected from step 3 that we are able to enhance the performance. In coming to my results, the table is taken from reference number 417, which is showing different performance measures of different machine learning algorithms, which is giving results based on imbalanced training and testing dataset. F1 score is taking mainly as it is harmonic mean between recall and precision. It tells us how robust, precise our classifier is. We are taking the F1 score to measure the performance based on the above table mentioned F1 score. We can say that random forest gives us the best performance than other machine learning algorithms for detection using imbalanced data set. Then coming to this slide, the figure 2 shows the imbalanced data set. Data set is made with 99.83% of genuine transactions and 0.17% of fraud transactions. So we have to balance the data set using the oversampling. Then the oversampled data set will be used for training and testing phase. We will use transaction amount and transaction time distribution to understand how good these features in the datasets are. For the privacy policy, we can get the names of the other features, but all the features went through PCA transformation, which means that they all are previously scaled. Then in second figure shows the results of the imbalanced dataset balance. The results now show that the dataset now consists of 50% genuine transaction and 50% of fraud transactions. SMOTE is used after cross-validation is done so that oversampling and data leakage problem will not happen. Now, this dataset will be trained and tested in machine learning algorithms. So here, it shows a high recall value, which means the model is able to find our highest number of fraud transactions. The precision shows very low, which is not good because it means the model classifies many genuine transactions as fraud transactions. It is very important to have a good precision value. Here, oversampling method is implemented with random forest, and random forest with smooth shows that best performance than logistic regression with smooth. It gives us a best result and high recall and precision value. The recall is gone lower a little bit, but also the precision is increased significantly, which means a lot in the case of fraud detection, as we know that it's a trade-off. So coming to the conclusion, good prediction results can be achieved by using balanced data sets. In this paper, random forest classifier gives us the best results with balanced data set. It helps us to detect more than 80% of fraud transaction cases. And at the same time, it's not classifying many non-fraudulent transaction cases as fraud. In this paper, SMOT is used with random forest classifier and logistic regression only and gives us a result that random forest with SMOT gives the best results. Random forest shows the best result both with balanced and imbalanced data sets. There is always been a trade-off between recall and precision. It always depends upon situation objectives to decide which approach is the best in each particular situation. So in my case, random forest with balanced data set gives us the best results, and it helps to find out to differentiate fraudulent and non-fraudulent transactions more than the other machine learning algorithms. I have gone through these are the references. Thank you.
Please come to your references. Mithul, are you able to hear me?
Yes. These are the references.
So these references are from 2021 because in your literature survey, you have taken only 2 papers. One was of 2017 and another was of 2021. That's all. So, okay, fine.
Hello.
Just specify what kind of frauds have you considered here? What kind of credit card fraud?
Is transactional frauds. Mainly
Transactional
transaction frauds based on amounts and time.
not about anything else like hacking your computers and phishing and stealing your mail.
Actually, I want to work on them in future.
So as of now, only transaction, and that's to which kind of transaction?
So
When you are logging in, only that transaction you are talking about?
No, if we are logging in and we have done some kind of transactions, like we have paid someone at a particular time, the time and the amount to a particular website or anyone is counted.
Okay, fine. Then you talked about that you have not modified your algorithm. You have only, what you have done is you have added SMOT with the random forest. That's all.
Yes, I have made an extra protection layer with SMOT that the random forest or other algorithms can understand better understand better. That's why they can, in real life scenario, they can differentiate more between fraudulent and non-fraudulent transactions. Actually main thing happens when the training phase happens. If we haven't learned them perfectly, they can't differentiate between fraudulent and non-fraudulent transaction, and they are biased with some kind of transaction that they are always telling that no, that's not fraud. That always happens. So my method is learn them properly with smart, with oversampling method, then use them from real life for real life scenario.
Making it better through random forest.
Yes.
Any question from other participants or audience? Any question from the audience? I think Sayuddin, sir, you want to speak something?
No, sir, it's okay. No question from my side. You may continue.
Okay.
Okay.
Thank you, Mithul and Swapan, for a nice presentation. So we can carry on with the other participant.
Okay. Thank you, sir.
Thank you.
It was very nice presentation. So on the list, our next presenter is Mirza Samiullah Beg and Dr. Akhilesh Evau. His presentation is on enhancing ABC with dynamic techniques to optimize the execution time. Hello.
Hello.
Mirza Samiullah Beg.
Yes, ma'am.
Yes,
Good
sir.
afternoon, ma'am.
Good afternoon. Sir, please put on your camera, please.
Okay, ma'am.
Yeah. Yeah.
Okay, ma'am.
Okay, sir.
Are you audible?
Yeah, you are audible
Yes,
and
ma'am.
visible too. Now you can present your screen.
Okay, ma'am.
So you will be given 10 minutes for presenting.
Okay, ma'am.
Okay? Yes.
Hello.
Yes, sir.
Yes, you are
Ma'am,
audible, sir.
Yeah,
my
your PPT,
presentation is
yeah, PPT visual. Now you can off your camera. No problem.
okay, ma'am.
Run the slide,
Thank
sir,
you, ma'am.
please.
Thank you.
Please run the slide.
Okay, ma'am.
Okay. Yeah, now your slide is visible.
Visible. Okay, ma'am. Thank you, ma'am. This is Mirza Samiullah Beg, and I am presenting my research paper on enhancing ABC with dynamic techniques to optimize the execution time in the International Conference on Emerging Trends in Artificial Intelligence and Smart Systems, TEEETA 2022. The content of my paper are as follows: introduction, objective, literature review, research method, result discussion, and conclusion and reference. Then my first slide is abstract of my research paper. The abstract of my paper, this paper deals with dynamic technique which is used in artificial P-colony algorithm to give better results. This technique is used in data optimization. So far, whatever artificial P-colony has been used in the field of technology takes more time in data optimization. Whereas when dynamic techniques are used in artificial P-colony algorithm, it takes less time for data optimization. Here I am using this technique to reduce the time and give better result for optimization. This technique comparison done in this paper. In this paper, the technique is comparison with particle for optimization and genetic algorithm. This algorithm, which one I used, is best for all of them. The introduction of the paper is many researchers introduced the idea of mobile sync based on the based on simulation colony in different mobile wireless sensor network. Data collecting is a basic process. Because they must transfer massive volume of data, nodes near the sink may get exhausted prematurely. A wireless sensor network is made up of large number of sensor nodes. Wireless sensor network efficiency is extended using a variety of energy efficient clustering techniques. The basic goal of wireless sensor network design is to have the network last as long as possible. The power consumption of LoRa nodes and the mesh network real-time responsiveness are incompatible. This article uses an updated artificial P-colony method to resolve this inconsistency.
The technique reduces data transmission overhead, save energy, improve the efficiency of network data collecting. An artificial colony algorithm is used to improve performance of mobile sensor network. The algorithm high performance indicates that it may be used to solve dynamic problems in such network. In this study, an artificial colony model is used to solve the issue of finding the best sorted path. The improved ABC model use a lot of energy and there will be data congestion, but it avoids the link level congestion that were previously associated with Prim's algorithm. The upgraded AI has a quick convergence speed and large coverage rate. According to the result, an artificial colony algorithm is used to improve performance of mobile sensor network. The algorithm high performance indicates that it may be used to solve dynamic issues in such networks. Introduction continue. The artificial colony algorithm is prominent thorn-based algorithm that is based on honeybee's clever foraging activity. ABC is quick and reliable approach for solving complicated non-linear optimization problems. It may be used to find quick solutions to variety of dynamic optimization issues. The contribution of this paper are as follows. ABC artificial colony algorithm use the dynamic technique. To pick a food source, follow the general scheme of the ABC algorithm, that is employee B, onlooker B and scout B phase. For searching data, implemented the employee B and onlooker phase in the dynamic technique. Objective of my research is, the objective of this technique is used to reduce the time and give a better result for optimization. And the second one is the technique is used to comparison with previously research like particle form optimization and genetic algorithm. Here I am comparison with both algorithms. Now review of literature. Here Khan and et al. Develop a self-organization based clustering technique for cluster formation and maintenance based on global form optimization. Cluster head selection and cluster formation are based on UAB, Lucifan value and residual energy, as well as their connectivity with the ground control. And again, next scholar is Yan Yang et al. Proposed a novel technique for solving numerical integration based on artificial global form optimization algorithm. The approach may compute the standard definite integral as well as singular and oscillatory integral for any function. The suggested approach has a great precision based on simulation findings. The Zanel et al. Global form optimization is a meta-heuristic method with no derivative. It imitates the global behavior which can efficiently capture all of the multimodal functionality. There are several flaws in locating the global optimal solution. You et al. To handle the wireless sensor network energy balancing problem and unwind cluster routing technique based on global form optimization for wireless sensor network is developed. The simulation result demonstrates that this method efficiently extends the life cycle of the network while managing energy dispersion. Literature review continue. Reddy et al. The goal of this study is to determine the best cluster head for energy efficient routing protocol in a wireless sensor network. Clustering is a good approach to provide a better route that doesn't cause any problem when transmitting data. The network will suffer from network failure if suitable cluster is not done. Hassan et al. When dealing with multidimensional data, many clustering techniques fail. Researcher has presented a new fuzzy approach with enhanced discrete artificial colony. For Jabi et al., clustering is a branch of unsupervised learning in which data is separated into clusters for comparable individuals. The approach has been tested on 9 UCE data set and 2 fake data sets. Q1 et al. NASABC outperformed 5 other ABC algorithms when compared to 22 benchmark issues used in trials, according to researchers at the University of Bristol. NASABC is a novel algorithm that uses a never radius based selection mechanism to identify appropriate food source for a bee colony. In this research paper, used research methodology are as algorithm for artificial colony algorithm using with dynamic technique. ABC algorithm was inspired by honeybee foraging behavior as much as possible gathered in bunches driven by pioneers, sometimes known as bundle head. With improved organization execution, the use of energy by group head CH will become more visible. The algorithm uses the following collection of algorithms. Here I am using the algorithm collection of algorithms. Here the first step of the algorithm population initialization of data optimization using ABC. And second step is following employee B phase of ABC algorithm, onlooker B phase of ABC algorithm, scout B phase of algorithm, ABC algorithm. Then result and discussion, the output performance of evaluation of my research is here. Figure depict the execution time or simulation time of the implemented suggested framework, the ABC method A, and a dynamic approach with varying number of nodes linked were used to compute the execution time. The 10th node lowest execution time is 8.2 seconds, while the 50th node maximum execution time 10.2 seconds. Here is my algorithm is executed, then give that result. And compare the other PSO and GA, according to figure, the simulation time of the developed suggested framework is the execution time with a different number of nodes. The execution time was calculated. The execution time was a minimum of 10 seconds. So that is proposed by my algorithm. Take time minimum of 10 seconds. And 30 seconds less than PSO taking maybe 50 seconds, 30 seconds and less than PSO, and 29 seconds less than GA, genetic algorithm. The conclusion of my paper is the execution time is compared with different number of nodes in this study. The suggested approach takes 10 seconds, while other algorithms such as PSO and GA take 30 and 29 seconds, respectively, which is longer than the proposed algorithm. As a result, the proposed algorithm is best. Result is best. Then reference of the research paper are as follows. Thank you.
Any question from the audience? Any questions from the audience?
Okay, sir, it's all okay. No question from my side. Okay. Thank you.
Mirza, you please come to that result and discussion slide.
Yes, sir. Yes, sir.
Previous to this one. Okay, one thing, you have taken only one graph. You have shown only efficiency time. You haven't taken any other parameters and compared it with your existing algorithm and other algorithms. Number one.
Sorry, sir?
You have compared only efficiency time, execution time, that's all.
Yes, sir. Execution
You haven't
time.
taken other parameters.
No, sir. Only execution time.
Because you have to consider other parameters as well. So like there should not be more overhead or some different things, or even at times security also. So all those parameters are to be considered. So I will suggest that you can add more parameters and you can add more graphs in your study.
Okay.
And can you explain all these lines? These you have written, this algorithm uses the following collection of algorithms. So can you explain these phases? What are these different phases?
Just okay, sir. So here, firstly, I am here first in this collection of algorithm. Here I am using the sphere function. Just a minute, sir. In the here population initialization of data optimization using ABC. Sorry. Just a minute, sir.
Hello.
Just.
So, Mr. Sir,
Yes.
please.
Yes,
Please
ma'am.
say loudly.
Yes.
You are
Yes.
not
Yes.
audible. Yes.
My voice is not audible, ma'am.
Now it's audible.
Okay, ma'am. Yes, ma'am. So in ABC algorithm, first I am population initialization of data optimization. Here I am take input like a fitness function. Here I am using lower bound, upper bound, population of nodes, iteration, limit, then initialization a random population, then evaluate objective function and fitness function. Then set the trial counter of food source equal to 0, or then after that I am using for loop for iteration for 1 to number of iteration. Then use the employee phase. Here I am perform the employee phase for all number of nodes, like 50 node, 100 node, and then determine the probability of each number of nodes. Perform onlooker phase to generate number of nodes, then memorize the node or result. Then finally I check the trial of any food source is greater than limit. Then perform scout phase of existed food source. Yes, sir.
Okay, thank you, sir. Thank you.
Okay.
Ma'am, we can call the next participant.
Okay. Okay. So our next candidate is Preeti Kumari, Lini Matthew, and Nilesh Kumar. Preeti Kumari and Preeti Kumari, are you there?
Yes, ma'am.
Okay. So please turn on your camera so that we can see.
Yes, ma'am.
Okay. So their topic is robotic control by EOG, EEG, RIFD based multimodal interface and shared control technology. Over to you, Preeti ma'am.
Yeah, okay. Thank you, ma'am.
Now please share your screen.
Yeah.
Please share your. Yeah.
Is it visible, ma'am?
No, still not visible. Presenting, go to presenting.
Yeah, ma'am. I'm going that. Well, the share option is not highlighted.
No, it's not visible. Present now. There is option.
Yeah, present
Fifth
now.
number option. Fifth number
Yeah.
option. Yeah, present now. Just click on that.
Okay.
Still your
Go to your entire screen. Select your entire screen,
yeah,
ma'am.
select your entire screen. Yeah.
Just wait, ma'am. There is some.
See, when you will click present now, then you
Yeah.
have to click your entire screen. Go to your entire screen.
Yeah, ma'am.
One-
I have clicked
Yeah,
on that.
one pop-up window will appear. Yeah, one
Yeah.
pop-up window will appear. Yeah. On
Yeah.
that, just click on your entire screen.
Okay. Yeah. Now the share option is highlighted.
Yeah.
Okay.
And
Now it's visible, ma'am?
Yeah, it's
okay.
visible now. Now
Okay.
you can close your camera. No problem.
Okay, ma'am.
So, ma'am, you are getting 10 minutes of time, okay, for your
Yeah.
presentation.
Yeah, okay, ma'am. Now the camera I can see. Now I can't see where.
Just
from
click
which-
on PPT. Yeah, click on your presentation.
yeah, ma'am. I just wanted to stop.
Just hide it. That sharing, stop sharing and hide button is there. Just press hide.
Okay.
Don't press on ha. Now
Yeah.
the camera is there. Now you can switch it off.
Okay.
Yeah.
Thank you, sir. Okay. Now it's visible, sir?
Yeah, it's visible
Yes,
now.
it is visible.
Yeah. Okay. Thank you, ma'am. So, a hearty good afternoon to all of you. Myself, Preeti Kumari, pursuing PhD from NITTTR Chandigarh, and I'm here to present my research paper titled Robotic Control by EOG EEG RFID based multimodal interface and share control technology. These are the list of contents to be covered. Let's start with the introduction to man-machine interface systems. So basically, man-machine interface means interaction between human and machine for any particular application or for any particular purpose. So the goal is to allow effective operation, control, management, or visualization of devices for decision-making processes. It encompasses hardware and software solutions for information exchange or communications. So man-machine interface can be a simple input like a touch display, or it can be a big application for control panels, like for highly complex industrial applications as well. It can have several applications in patient monitoring or maybe in healthcare as well, like for BCI applications, which we are using here. So there are many type of man-machine interface systems. Here we have used biosignal-based man-machine interface systems. So here are some examples that we given. Like in the first one, the first one shows that the chair is controlled by brain signals, and in the second one, the an EMG signal, that is the muscle signal, is used for some gaming applications, and in the third one, the EOG signal, that is eye signals, are used for controlling a wheelchair. So here in this work, we have used EOG and EEG signal, that is electrooculogram and electroencephalogram. So electrooculogram is the eye signal and electroencephalogram is brain signal, basically. So let's have a brief definition. So electrooculogram means the eyeballs act as a dipole with a positive pole in the cornea and a negative pole in the retina. So when we change the position of the eyeball, like when we see in the left direction or right direction, or in up direction or down direction, so the eyeball moves, so position of the eyeball changes and the potential of the skin changes as well. So the plot of eye potential referred as an electrooculogram. Then the second signal which we have used here is electroencephalogram, that is a brain signal. So there are different brain patterns which we get due to different phenomena. So here, one of them is steady state visual evoked potential, which we have used here. So when we give some visual stimulus to the brain, or we can say when we see some visual like LED blinking, like so there is some stimulation in the brain, and corresponding there will be signal which we can see in the occipital lobe of the brain, that is in the backside area of the brain, is called occipital area. So the resulting potential generated by the visual cortex can be recorded as some particular positions of the brain, which already international standard, that is called 1020 standard system. So visual stimulus, when that visual stimulus frequency is over 6 hertz, then it leads to a sinusoidal shape of the corresponding EEG signal. And this phenomenon is called steady state visual evoked potential. So these two signals have been used in our work. So we can use any one signal also for man-machine interface system, as we have given that examples in the previous slides. But as we know, as we have studied from the literature, any single modality, whether it is EMG signal, that is electromyogram, that is muscle signals, or EEG signal, that is electroencephalogram, or EOG signal, any single modality can only manage one certain kind of task. For example, EOG is a very good option for movement control application. EMG is very good option for grasping application, or EEG is very good option from some triggering applications. So when we want some universally robust system, so it is very difficult to have that robust system for by using only single modality. So for that, to get that robust systems, we have to use more than one modality simultaneously. So that is called multimodal system, to make the system much more efficient or much more effective. Or there is another benefit, when we use only one modality for the long time, so there will be a fatigue to the human, or maybe some tiredness, or apart from that, when we use multimodal system, so there will be less fatigue to the subject as well. So here as we can see that in the example, there are three signals: EMG, UOG, and EEG have been collected simultaneously. So this is the called multimodal system, when we are acquiring more than one modality simultaneously for a particular application. Again, furthermore, whether we are using single modal or multimodal, use of biosignals interface alone can have some limitations, because here again the human limitations will be there. So for that, we cannot achieve more precise and complex manipulation of control commands. So for that, we can combine some other technology, some other control technology along with our biosignal interface. So that is called shared control technology. Means combining biomedical signal interface with some other technology, that can be some embedded technology, can be RFID technology, can be IR sensors. So in this way, the total control task will be shared between two control technologies. So that will be more efficient, or we can have more better, or more better you can say output for different applications. For some complex applications, like for example, shared control has been already used in the literature for robotic controls, or to aid blind people to improve mobility to them. Again here, when we acquire the biosignals, so we cannot use them directly to control any external devices. For that, we need to process them, and we need to convert them to control commands. So for that, we have to use very widely used machine learning techniques. So application of machine learning in man-machine interface is very widely used nowadays for classification problem. So machine learning technique is basically here we used for classification problem. So in the data classification, each object is described by a set of attribute values. Those attribute values is actually features which we calculate from the raw data. The feature set will be calculated, and then each object belongs to one of the predefined classes. So the goal is to derive a set of rules that predict which class a new object should belong to. So based on the given set of training data, first we train with the given data, and the given classes, then we can predict the new data should go to which class. So for that, we use machine learning techniques in man-machine interface system. The author has already reviewed many papers, many research papers to reach at the actual problem. So, but very few we can I have collected here due to short of time. So which some important papers only I have taken here. Like for example, here in 2013, a research paper have been published in Journal of Medical and Biological Engineering that is based on actually EEG signal, where we classify the EOG signal from EEG signal. So here the strength of the paper, or you can say the paper actually proposes a simple algorithm for offline recognition of 4 direction of eye movements. So here they have used a thresholding method for classifying the EOG signal, but the author have already suggested that hybrid BCI or hybrid MMI system based on EEG and EOG will be more suitable for practical machine control, or maybe some potentially portable. So they have already suggested that multimodal system will be more beneficial. In another research paper in 2019, researchers have published papers when they have combined EOG and EEG signal in hybrid mode, where EOG is used for the movement control and EEG used for opening and closing of the hand exoskeleton system. EOG have mean success rate of EOG was 99.85%, but the success rate of EEG signal was only 63.7.75%. So which we need to improve. In another paper, EOG and EEG has been used in hybrid mode, but they have also suggested that more powerful algorithms are needed to correctly recognize irregular eye movements, or and the next one is the training time. Training time was high in that paper, so that affects the accuracy. Also, the ITR of ERP, they have used ERP signal, ERP brain pattern. So ITR, that is information transfer rate, was also a major issue for the performance, which affect the performance of the system. In another paper, the researchers have used EOG and RFID signal in shared control mode. Just as we discussed earlier in the introduction part, the EOG has been used for movement control and RFID has been used for object interaction. So this is the example of shared control technology, but still they told that need to implement an automatic online adjustment of the EOG threshold. They have done the experiment in offline mode, and also the threshold which they have used for EOG classification, that was not auto adjustable. So that was the gap of the paper. In 2017, another research paper has been published. They suggested that if we connect multimodal interface and shared control simultaneously or together, so the performance of the system or performance of the system can be much improved, or the control commands has been increased, can be increased widely increased. Okay, so based on this literature, there are different research, many research gaps has been identified, and few important research gaps I have discussed here. I'm discussing here, like exploring novel multimodal biosignal features, comparing different classifiers, and are the research scope in the near future. So still there are scope that for multimodal biosignal features. Sorry. Another one is there is a need for more multimodal fusion of physiological signals in near future to further enhance the controlling commands and to increase feasibility and usability of the system. A man-machine interface system based on multimodal and shared control architecture, where multimodal interface can take decisions about the movement and the interaction with objects can be assisted by shared control technology, can be another research gap or a research scope in future. Next one is machine learning classification algorithms can be incorporated with traditional approaches to get better classification results. Motivated from this research gaps, I have identified my objectives as to develop a steady state visual evoked potential SSVEP based EEG interface to increase its performance, and to develop a classification algorithm for EOG interface to improve efficiency and accuracy. The third one is that to develop EEG, EOG based multimodal interface system where data will be directly transmitted to the computer and displayed in real time. The next one is to design RFID based shared control architecture with EEG and EOG based multimodal MMI system. To investigate the viability of the proposed scheme by carrying out experimental testing and validation. And the next one is to develop a prototype mobile robot which will be controlled by EEG, EOG, RFID based multimodal interface and shared control technology architecture. So this is the research methodology of the proposed work. Here we will start from here. The EOG and EEG signal will be acquired from the subject, from the human subject with some machinery like data acquisition system. Then the data will be pre-processed. The raw data, the raw biosignal data will be pre-processed, like we use some filtering to avoid the noises. Here we have to use 50 hertz. Here we have to use filter to remove the power line interference, and another noises or artifacts will be removed in this pre-processing stage. In the next stage, we have to extract some relevant features. As we have told, the raw biosignals cannot be classified by classifier or any technique. So for that, we have to convert them in relevant, in some different form, that is called attribute, in different attribute, and that is called feature vector. There are when we combine a number of features, that is called feature vectors. So using those feature vectors, those feature vector or those feature values, we have to train the classifier. First, we need to identify a classifier, which classifier we are going to use, or which machine learning technique we are going to use for our problem. So that classifier will be trained using the training data. So in training data, the data and the classes both will be given simultaneously to train the classifier. So according to those training data, the classification parameters will be updated throughout the training process. The classification parameters will be updated, and the final optimized classification parameters will be finalized for the testing process. So when the optimized classification parameters are obtained, then we will give the test data to the classifier to test the performance of the classifier. So here we have used LDA classifier, that is linear discriminant analysis classifier, for our problem. Here then when the classifier is trained, then the multimodal interface, that is the EOG interface, EOG and EEG in multimodal interface, has been used for controlling the movement of a robot. So here, assistive device, a prototype mobile robot has been developed in our lab, and that robot, the movement of the robot is controlled by the EEG and EOG signals. The robot will move in left and right direction according to the EOG signal. When we move the eyeball in the left direction, robot will move in the same direction. When we move the eyeball in the right direction, the robot will move in the right direction. Then the EEG signal, the 3 EEG signals has been used for two EOG signal, horizontal EOG signal, and 3 EEG signal has been used to control the robot. So three EEG signal is used. So one is for forward, one is for backward direction, and one is for emergency alarm. If the patient or the subject, as we have already discussed, that this proposed work can be used for healthcare applications. So if the patient or the subject wants to generate some emergency alarm, so that can be generated by the EEG signals. So these movements and the emergency alarm will be controlled by the multimodal interface system. Then the final application is the robot has to pick or place some object which the subject which subject want to pick or place. So that pick and place application will be controlled by the RFID application. So the total movement is controlled by the multimodal interface, that is biosignal, and the object interaction is controlled by the by the RFID technology, that is shared control technology. So this is the complete research methodology in the block diagram, which is shown in the block diagram. So this is the algorithm for proposed multimodal interface. As we have said, so two interface systems has been developed. One is for EOG signal, one is for EEG signal. There are two different algorithms has been developed for detecting the EOG signal. The thresholding method has been used. A different algorithm has been written for detecting the EOG signal. And for SSBP signal or for EEG signal, there is different algorithm. That is, both the algorithms has been run in the in MATLAB Simulink, and then both the interface system, both the models has been combined in a single model, single Simulink model, to get the multimodal interface or to get the multimodal control commands to control the mobile robot. So here is the application. So here there is a priority signal has been defined. That is actually a particular EEG signal has been chosen as a priority selector. Like, for example, when we are sending the EEG signal, the eyeball can move simultaneously. So which signal will be taken as a priority, that is also decided, so that there will be smooth switch between EEG mode and EOG mode.
I'm sorry, ma'am, the time is already exceeded. So could you please be fast?
Yeah, sir. Yeah, sorry, sir. Yeah. So now the result part is here. I'm already, sir, ending that part. The result is first of all, as I said, the first one is the EOG interface. So the performance, this is the raw EOG signal for the left movement and the right movement, and this is the corresponding control signal. So from the output, we can see that the control signal is that is, as here we get 100% accuracy for the EOG interface for our threshold application, threshold algorithm which we have developed. Like here, the control signals 3 and 4 we have already we have calibrated the control signals in 3 and 4 values. So for the right movement, the control signal is 3. For the left movement, the control signal is 4. So this from here we can say that the output is 100% correct. So here the algorithm gives the 100% classification accuracy. For the EEG movement, for the EEG performance, the LDA classifier has been trained, and during training, here is the point where we get the lowest classification error. That is means highest classification accuracy, which we finalize for the testing, for the final testing of the data. This is the data which we get during training, and from here you can see that the total error of the EEG interface was 10% for the 4 classes, but when we take for the 3 classes, so the error was only 5%. So that's why for our application we have taken only 3 classes for EEG signal to improve the accuracy of the system. So this is the final application process. This is the mobile robot which we have developed in our lab. Here we have used Arduino controllers to convert the biosignal from the Simulink model to the robot to control the robot movement, robot wheels. Here we can see the RFID reader has been connected to the end effector of the robot, and the gripper is connected. So the gripper will move according to the EEG and EOG multimodal interface to the zone 2, where the object will be placed. And here a tag, RFID tag, is connected with the object. So when the tag will be in the range of RFID, it will read the tag information. If the tag ID is same as written in the program, that is the beep beep will be a buzzer will be beep that the object has been identified. Then the robot will pick the object and move to the zone 1. So here there is an empty space. Here the robot will place the object and then go to the initial position, will reset to the initial position. So this pick and place application was completely controlled by RFID. That is not controlled by biosignal. So the total control was shared between 2 technology. So the subject will feel less tedious and less fatigue for this complex problem. So this is the performance of this. Here we can here we have calculated the total speed of the robot to complete the total task, and this is the EOG accuracy and EEG accuracy. Though here you can see that EUG has the 100% accuracy, means all the subjects have completed all the sessions with the 100% accuracy. That is, out of four has been given, four has been given the 100% accuracy. And the EEG, there are some errors. We have not get that 100% accuracy, but that was a satisfactory result. And here that the speed result was indexed with speed in the index was calculated and has been plotted in this graph. Now the conclusion that combining a multimodal interface and shared control architecture for a pick and place application can be a good mobility system technique for disabled as well as healthy people as well. And the proposed algorithm and the use of RFID ensured reaching to the right object through the shortest path while taking lesser time. So this can be this can be used for any further applications with very little modifications, and by adding more modalities, we can have more control commands, and it can be used for many complex tasks as well. So these are the references. Thank you.
Okay, so any questions from the audience, please? Ma'am, I want that presentation. Please come to the presentation.
Yes, sir.
Come to that your methodology part.
Yes, sir.
Ma'am, actually you were saying that with the help of eye movement and with that is EOG.
Yeah.
So EOG will be taking care of eye movements.
Yeah.
And EEG will be taking care of your brain signals.
Yes, sir.
And then finally, what robot is supposed to do is, based on these signals, he will be picking a object.
Yes, sir.
But then what RFID will be doing? Because you said that with the help of RFID, it will be identifying that object.
Yeah. That I. So actually, the EOG and EEG based multimodal system is used for the movement of the robot, and after the movement, the picking and
place. But sorry, I'm interrupting you.
Yeah.
You showed that empty space, and you said that once the object is identified, it will be taken to that empty space. That means again that is already empty identified, and once the object is identified, you will be picking it up and will be taking to that empty space, which is already identified. So why this movement, why this EOG and EEG will come into picture? Because again, now you are not controlling through eye and brain, because it has been already identified.
Yeah.
So it will be picking and just dropping it there, placing it there in your sense.
Yeah, sir. Actually, this application, what was in my mind, like for example, a person which cannot move, maybe he is paralyzed, or maybe on the wheelchair, or maybe on the bed with the patient. So, and he want to have some glass of water, or he want to pick some medicine, or that medicine is a little bit far away in the range in his end. So if we use this type of robotic application, so this is just a prototype, so this is a small one. But if we want to have some practical applications, so accordingly we will design the robot. So the robot he will not be dependent on any other person or any other attendant. He can reach to the object by himself using his own biosignals. He cannot move, but mostly in most of the cases, if the person is paralyzed or maybe he cannot move, still the eye signals is intact. He can move his eye signals, or if he can have some brain signals as well. So
that is okay. That is okay. But then how RFID is helping us? Yeah,
that's I'm coming to that point. So for example, there are more than 3-4 medicines. So if the robot will reach in the range of that place where there are more than 4 or 5 medicines are kept, and he has to pick some particular medicine, for example. Okay, so we will put the RFID tag on that medicine only, or you can say all the medicines have different tag ID. If we will put the tag for a tag in every medicine, so in every tag we will have different tag ID. So which tag ID we want, that will be written in the program. So accordingly, the RFID will identify that tag only. If
Ma'am, if this is already mentioned in the program, that means only one thing the robot is supposed to do, that is picking up a specified medicine only.
yeah, exactly. That's what I'm saying. Yeah.
But if next time if he has to change that medicine, that won't be done.
Yeah, yes, sir. For that same
Because
place,
4 medicines are there, so next time maybe I may be taking some different medicine.
yeah, but
That
that's
person may be taking some different
if
medicine.
at the same place, some other medicine will be is placed, or maybe some other object is placed, so it will beep a buzzer that if that the object is not identified, or the object is not there is no object. So for that it will beep a buzzer. Okay.
But
And
it will not pick it up, because next time if I have to select some different medicine, or that patient has to select some different medicine, so that will not be a possible for that robot. It will only beep, that's all.
yeah. For a particular application only we can use that.
So this can be improved a bit, in a sense that the robot can identify also that these objects.
Yeah, sir. As I told you that in the program we can write the tag ID as well as the other information of the object. For example, the dimension of the object, the color of the object. So in that way we can identify more object as well. So in this way we can improve. As I told you, there is a very large scope of the research in this field.
Fine. Thank you.
Yeah. Okay. Thank you, sir.
Any other questions from the audience, please? If anyone wants to ask. Okay, ma'am. Thank you.
Okay. Thank you, sir. Thank you, ma'am.
Thank you, ma'am.
Thank you.
So our next presenter is Bamleshwar Rao, Mr. Bamleshwar Rao, and Dr. Akhilesh A. Rao. Their paper topic is User Authentication System for Securing and Identifies by User and IoT Device. Bamleshwar sir, are you logging? Hello? Hello?
Yes, ma'am.
Yeah. So you can continue. Please share your screen.
Yeah, ma'am.
Hello.
Yeah, run the PPT. Yeah, now it's visible. You can start now.
Okay, ma'am. Good afternoon, everyone. My topic is a user authentication system for securing and identifies by user and IoT device. Contents are our report. This is the introduction. The primary goal of secured IoT is safeguard IoT data for wide range of security threats and attacks. Are you audible, ma'am? Hello.
Yes, you are audible. Please go ahead.
Authenticating IoT people rather than the devices they use becoming increasingly widespread in the IoT security solution. As the number of interconnected device continues to expand at an exponential rate, security weakness are becoming increasing frequently, increasing the likelihood of cyber attack occurring. Therefore, fraudsters will have the opportunity to exploit these domains. These figures describe the authentication system by user and devices. Moving further, our objective is we need to design authentication which provide security for hardware level, software level, and network level. In this module, it provides a secure sensor data and IoT devices. Symmetric views aim to present good analysis of research topic by employing and trustworthy auditable methodology, and multiple security framework are upgrading existing security framework in IoT. Next, literature review. R. Miller et al. It is possible to develop virtual reality application that require real-time behavioral verification of user and provide secure access to content using our technology. Next, Y. GU et al. This research are being done as develop a behavior characterization technique that is specifically suited to prototype network to make it easier extract domain independent behavior feature, while also making it is possible to identify new user in a new environment in a single step. Next, LU et al. To create balanced binary tree based authentication protocol that recognize and identifies each individual by combining binary classifiers. Y. Ashibani et al. Test on the proposed model resulted that it is effective and authentic user with the best accuracy. L. Chain et al. A new feature extraction method are employed a collect user behavior feature from data, and then fusion technology is to identify user who have exhibited such characteristics. In this research, we can identify whether or not the current user is normal human based on the outcome of the recognition process. Next contain research methodology. IoT devices that are now being developed on individual basis. As improved cryptography algorithm has been developed over the past few years, it has become increasingly difficulty to rely on old cryptography procedure to safeguard sensitive information. Next, to achieve it important goal of identifying solution for problems that arise when the data is used in IoT application and infrastructures. One of the most significant objective of this research is to identify a problem that arise when data is used in the IoT application and infrastructure. Next, once it has been determined that verification process was successful, the technique moves on the authentication portion of the operation. Once and the authentication attempt has failed, due to patient or medical device failure to authenticate, the login request is forwarded to the registration process. The authentication mechanism is initiated in the background when the successful login attempt has been completed. Ongoing research is developed or focused on creation of lightweighted block cipher for the protection of medical data against hostile hackers. There are several risk challenges related to managing and large volume of the data generated by the IoT. As the IoT ecosystem expands, its reach as a grow and popularity. During data transmission, it is critical to consider the amount of processing power, the amount of energy consumed. An advanced security algorithm is required to overcome such difficult as prevent unauthorized user from having access to sensitive information about another individual. Even though there are several security algorithms available to authenticate remote user based on traditional password, biometrics, and other facts with varying efficiency. Algorithm uh, is more efficient and providing complete protection of login time authentication to remote user. Next, result and discussion. The hybrid OTP generating technique as
You are not audible, sir. Sir, you are not audible.
Are you audible, sir?
Now
Hello?
you're audible, but your last few slides are not we can't hear 3 to 4 slides.
Result and discussion part, no, sir?
Hanji?
Uh,
Okay,
result and discussion part.
Any questions from the audience, please? See, I'm not able to understand. Actually, you were not audible at your result and discussion time. So, what exactly you want to portray over here? What exactly you want to explain in this particular slide?
Which slide, sir?
This the slide which is shown right now, results and discussion. What exactly you want to convey? The features part is blank. Then, am I audible, sir? Am I audible to others? Am I audible to others? Anyone, please respond.
Yes, sir.
Fine.
Yes, sir. Yes, sir. You are audible.
Yes, Bamleshwar Rao, sir. I just want to know that what exactly you want to explain in result and discussion.
Actually, sir, it is a totally OTP generated technique, sir. This is tested on desktop computer and Android also.
No, but where are the results, sir? Okay, fine. Can you come to your that methodology slide? Proposed methodology or methodology? Sir, actually, see, what you want to convey over here is you want to develop a sensitive information system. Then again, you are identifying problems and then you are giving solution for that. Again, you are verification, some verification part is done, and then in the last, you are applying some advanced security algorithm. So all these things is done in your study.
Yes, sir.
All these things are done. Which security algorithm have you used? Okay, fine. Thank you. Any other questions from the audience? Thank you, sir. Ma'am, are you there? Can we have another participant, please? Sir, you can unmute your screen and you can mute yourself.
Hello.
You
Yes,
can
ma'am.
mute yourself.
Ma'am, please carry on for the next presentation. Yeah, am I audible?
Yes, sir, you are audible.
Yeah. Yes, Mr. Bamleshwar.
You please unshare your screen and mute your mic, please. Please mute your mic. Ma'am, can we have the another participant, please? I think ma'am is not here. Who is the other participant? Those who are there in the meeting?
Sir,
Can
I
any
am.
one of you?
Yes,
Yeah,
sir.
next one is Om Swarup Thakur. Yes, sir.
Yes, sir.
Okay.
Please share your screen.
Okay, sir. So I'll share my screen. Sir, is my screen visible?
Yes, please.
Yes, sir.
Okay. So, good evening, everyone. My name is Om Swarup Thakur, and I am from Department of Computer Science and Engineering, Manit, Bhopal. So, I will be presenting my paper. The title of my paper is Textual Analysis of COVID-19
Sir,
Review.
can you switch on the camera for some time because recording is on?
Sure.
Then you can switch it off after
Sure, sir.
some time.
Am I visible?
Fine. You can switch it off and then you can start sharing the screen.
Sure, sir.
Hello.
Yeah. So, sir, should I go ahead?
Yes, please. Just make it in the PPT presentation mode and please.
Yeah. So, is it in my slide in presentation mode, sir, right now?
Yes, it is visible.
Okay. So the title of my paper is Textual Analysis of Code.
So you are a PhD scholar or MTech scholar?
MTech scholar, sir.
Okay, fine.
So the title of my paper is Textual Analysis of COVID-19, a review. So these are the contents of my slide. So I'll start with the introduction. So the COVID-19 disease, as we all know, has affected everyone's life in this around this world as from its inception. So there are usage of online websites such as Twitter, Facebook, Reddit, and in these websites, people participate in online discussions, send messages, express their views, and share their opinions. And this COVID-19 virus started from China. The virus name is SARS-CoV-2, and it gave rise to the COVID-19 pandemic, as termed by the WHO. And millions of cases and large number of deaths has been reported because of this virus. And now the technology has transformed the way people express their thoughts as compared to the earlier days. Now, a large dispersal of COVID-19 news is also taking place, is also circulating around social media as well as news websites. As a result, the social media platforms are generating a variety of data which carries sentiments, viewpoints, as well as their emotions in any situation such as the COVID-19 pandemic. So these large amount of data are very crucial as for the researchers as well as the computer scientists, and also for those organizations that are dealing with the pandemic. So for studying the sentiment of the this express or as their viewpoints, it is very important. So notable recent results can be yielded from this analysis of these data that are being generated. So this review will give the insights into the various studies which are being done on the COVID-19 text data, and will give an overview of the findings. So the objective of the study is, like as I discussed earlier, that the COVID-19 text carries variety of sentiments, emotions. So from the text we can generate, we can evaluate sentiments, topics, emotion of the COVID-19 text data. And the intention of this paper is to review the related research in the field of textual analysis. So the uh, major fields in which or major ways we can analyze is the topic modeling, which is the NLP. So these are the ways I'm telling is these are the NLP techniques: topic modeling, emotion detection, sentiment analysis, text summarization. This can be done, and useful, very crucial data can be extracted from these data. So various techniques have been applied for getting the opinions or sentiments, and for the textual analysis, such as machine learning, deep learning, lexicon based approaches, as well as, so these are the methodologies. So after investigating these methodologies in totality, the method BERT, which are based on BERT, which is proposed by Google, it is a method proposed by Google, and the models based on BERT perform better than the other approaches, as they carry up the contextual aspect of that text also. And the Bernoulli Nav based, which is a traditional machine learning model, gives the least performance among these methodologies. So since manual judgment and evaluation of these sentiments, emotion, and all those things is very challenging, because because every day large amount of data has been produced, so it is infeasible to do it manually. So there is a need of comprehensive and systematic analysis of this vast text data, and it is the motivation of the work. So I'll come to the related works and the surveys which are the approaches which has been applied. So I'll talk about the first approach. So in this first approach, they have used Jalodar H et al. They have used LDA method, which is a topic modeling method for topic modeling, and LSTM recurrent neural networks. And the data set that they have taken is the subreddits related to the coronavirus, and they achieved an accuracy of 81.15%. The next study which has been done in this is mentioned here. So RFSCR et al. 2. So they have used an LDA model, which is a topic modeling based model, and they have taken the Facebook data set. So they have mainly concerned about the two communities, so like pro-vaccination communities and anti-vaccine communities, and they have evaluated the coherence score. So what basically a coherence score tells the efficiency or like the performance of the topic modeling approach. The next approach, they have utilized the LSTM model, and the dataset they have utilized is the trending hashtag dataset from Twitter, and they have also used the standard Kaggle dataset, and from that they have achieved an accuracy of 82.4%. After that, coming to the next method, in this the tweets related to the reopening of the in the United States, the tweets related to those are considered, and what they have utilized is they have utilized name-based method, and they have achieved a 91% of accuracy in that dataset particularly. After that, the next study that has been given here is the Needful. It is a tweet analysis platform, and what they have done is, for classification purpose, they have used SVM model, support vector machine model, and And along with that, psychological need recognition models also used. And what the data set that they have considered is particularly based on the tweet hashtags, which are particularly in the New York State. And they have achieved the best accuracy by NSM model of 93.57%. And they have also considered got the most pronounced percentage also. After that, in the next study, this study given by M. Baja, in this, what they have done is they have trying to find out the link between COVID-19 5G networks. So what they have done in this is they have considered Twitter tweets related to COVID-19 and 5G, only those tweets. And on that, they have applied LDA topic modeling, weather model, which is a unsupervised sentiment analysis model, and social network analysis approach. And in this, what they have found out is like coronavirus has the highest degree centrality of 0.19%, and between a centrality of 0.2%, 0.2 value. The next approach is the given by RL Rosa, and in this they have used the tree CNN, and also along with this they have used deep belief networks. And in this they have considered the data set of Twitter as well as Sina Weibo. So Sina Weibo is like Twitter, but it is operated in China. So in China they don't have Twitter, so they have their own Twitter-like application, Sina Weibo. So they have used these two data sets, and from that they have got these results like 81.7% for the they have achieved accuracy of 87% for US election data set, 86% of US Manhattan data set, and 93% for COVID-19 symptom data set. After that, the next approach in this, A. Morat gave a mixed ontology data analytics results methodology, and they have utilized the Twitter data sets. So in this 16.1% tweets redirects user to out of context. So like what they have found out, it's like 16.1% of the tweets redirects the user to out of context. Means like instead of talking about the COVID-19, they talk about something else, and around out of context as well as for advertisements also. And 93.7% tweets were misleading as per their study. The next approach that has been given is given by T. Da Young, and in this they have particularly used Sina Weibo dataset, and in this they have applied linear probability model, random forest model, and linear regression model. And in this they have achieved precision of 81.39%, recall of 81.69%, and F1 score of 81.07%. The next approach is a map reduce is given by F. S. Sabri, and in this they have used the improved ID3 decision tree classifier, and as well as Hadoop framework and word2vec and globe embedding. These are the two embedding methods. And in this they have used two datasets from Kaggle, and these are based on Twitter only. So the name of the datasets were Sentiment 140 and COVID-19 Sentiment dataset. And in this they have achieved the following results: F1 score of 85.54%, and the kappa percent of 87.69%, precision of 86.67%, and following. After that, the next approach is the given by P. Garcia. So in this they have considered the news headlines and articles of 4 nations, and in this they have, for classification purpose, they have used Roberta model, which is a robustly optimized BERT model, which is a classification model based on BERT, and they have used top-to-back model for topic modeling purpose. And the dataset they have used, as I have mentioned, is COVID-19 news headlines and articles, and in this they have achieved an accuracy of 90%. After that, the next approach is given by XWAN, and in this they have used two approaches. The first is the text rank and BART for text summarization. Means like for text summarization they have used two approaches, the text rank approach and BART approach. And in this, the dataset that they have used is US media articles, like news particularly from the US media, and these news related to only coronavirus. And in this they have got the highest rogue score of 50.45%. So what a rogue score is? Rogue score stands for recall oriented understudy for gesting evolution. So basically it is a it is a way to get the similarity between the documents. The next approach is given by T. Wang, and in this they have used the NLP method of BERT and TF-IDF model, and they have used the Sino-Vivo data set from the duration of 1 January.
Please be fast, sir.
Sure. Of 1 January to 18 February, and they have achieved the following 75.6% accuracy. The next approach is given by MK Elhad, and in this they have used assemble method techniques based on 10 machine learning algorithms, and the data set was from WHO, and they achieved the accuracy of 99.68%. The next approach is given by XU et al. 15, and this methodology used the Vedder method, as I mentioned earlier, which is a unsupervised sentiment analysis approach, and the data set they have used is geotag tweets from data port, IEEE data port, and the following is the results they have obtained. The last approach that I'm mentioning is the given by P. Gupta, and in this they have used various classifiers from based on Twitter data set, and the best accuracy that they have got is like 84.4%. So coming to the for analyzing the text data, there is a there is a necessary requirement for the pre-processing. So I'll be telling the pre-processing steps. So first the data should be annotated. After that, the impurities should be removed, like removal of hashtags and unnecessary data. After that, the punctuations is removed from the text data, and from then after that, the text data is tokenized into, it is converted into tokens, and then there is a removal of stopwords. So what stopwords are? Like words like of, the, is. So these don't have sentiment value, so these are removed. After that, a stemming is done, and then lemmatization is done. So I'll be explaining few of the methodologies in here. So this is a methodology given by Ali Sariq Imran, as I mentioned earlier. So I will be explaining it in detail. So what they have done is they have used Kaggle dataset and trading hashtag datasets, and they have used deep learning, the technique called LSTM. And in this, they have used deep belief networks and followed by a greedy network using restricted Boltzmann machine to classify the sentiments as well as the emotions from the emoticons. And they have achieved accuracy of 82.4%. And what interestingly, what they have done is they have got the emotions from the emoticons also. And the goal was they wanted to see if there is a link between people feelings and emotions. And in this study, they have done that. After that, the next study I'll be mentioning is the Piyush Ghashia. And in this, what they have done is they have used two pipelines. So first they have done for articles, and the next pipeline they have done for headline. So for the articles, they have used topic modeling method named top to back. And for the classification, they have used the Roberta method. So in their analysis, what they have obtained is like the issue which were majorly reported in the 4 countries, Britain, India, Japan, and Korea, were economy, education, and sports. And also from their analysis, they obtained that UK has the most negative news related to coronavirus, and the UK was badly hit during that time also. So in this, they have used the duration of that collection of news were for 11 months. The next methodology is given by Harmeet Jelodar, and in this they have used LSTM as well as RNA approaches. So in this, they have used they have achieved an accuracy of 81.15%, and in this study, data from healthcare forums website like Reddit, in which there are subreddit, has been utilized, and on these subreddits, LSTM model has been applied. So in this, first they have used the embedding layer, then they have used the LSTM layer. After that, they applied the dropout, and again one more LSTM layer, and followed by dropout and softmax layer. Along with this, they have also used GIMP sampling in this, and for the topic modeling purpose, they have used LDA. The next method that I'll be explaining is this one. So T. Wang proposed this methodology, and in this they have considered the Sino-Vivo post, and they utilize around 90,000 Sino-Vivo posts related to coronavirus from the duration of 1 January to 18 February. And in this, they have used Chinese BERT based model for applying this, and then after that they have passed the data through softmax layer, and they have obtained the positive, negative, and neutral tweets from that. And along with this, they have also done topic modeling using the TF-IDF approach. So coming to the conclusion, so in this, as the intention of this paper, many types of researches has been explained in this, and the data sets that have been taken from various sources such as Reddit, Facebook, and other platforms like Twitter, Sanavibu, and along with this social media platforms, the news articles and headlines also been applied, has been utilized. And the topic modeling techniques such as LDA, Top2Vec have been extensively used. These two topic modeling techniques have been used by majority of the papers, and deep learning approaches such as LSTM, CNN, as well as BERT has been utilized. Also, in totality, if we compare, the Roberta model that has been used performed very better in terms of contextual analysis also, and in terms of accuracy also, and the Bernoulli Nav-based model performed the least. And along with this, the results that they have expressed has been in terms of accuracy, recall, precision, F1 score, and also some of the results that has been mentioned in the papers is in terms of the degree centrality measures also. So coming to the limitations among them, like most of the proposed methodologies were vulnerable to spam posts. So if there is a bot activity in spam post, the methodologies are vulnerable to that. Also, the techniques were not able to detect the sarcasm in the text efficiently, and future work can be done to can be performed in this direction to overcome these limitations. And the data also that are available currently necessary for handling outbreaks of similar nature can be used from this, and can be these limitations can be overcome in future. And in this, we all stand together in this tough times, and using technology we can overcome these adversities like COVID-19 from resurfacing. So these are my references that have been referred. Thank you.
So this is basically review paper.
Yes, sir.
Okay, fine. So any questions from the audience? Okay, thank you. Thank you very much.
Thank you, sir.
So who is the last one who is left? I think Pragya madam has joined, but she left again. So who is the last one?
Sir, here I am Ashutosh Mohite.
Please start.
Yes.
Please share your screen and start.
Yeah, yes, yes. Sir, I am audible.
Yes, you are audible, and your screen is also visible.
Yes, sir. Sir, myself Ashutosh Mohite. I am a PhD scholar in
Thank
AKS
you.
University Satna, Department of Computer Science. My paper ID is 37, and the title is Analysis of Supervised Machine Learning Classifier Techniques Used in the Gesture Classification. Here is a table of contents. We discuss one by one. Introduction. In the present era, we use different types of smart devices and gadgets, and we can communicate and handle these gadgets and devices with the use of gesture techniques or symbolic language. When we perform any operation in the real world data may be complex, noisy, and difficult to handle. Similarly, when we talk about to handle the devices or the sensor devices, in the gesture classification, the data in which we want to work may be complex or the large, and here in this technique we have to classify the data, complex data. So the data classification, the process of data classification plays an important role in the gesture phase classification in the human computer interaction. In this study, we mainly compare the 5 different supervised classification algorithms which are used for the classification in the machine learning technique. Here the objective of our study The main purpose of the study to describe and explain the previous research has been done in the classification in the field of SCI, human-computer interaction. The another objective is to provide an introduction about five different kinds of supervised machine learning classifiers used in the classification, and compare the classifiers on the basis of different parameters. Here are some literature review. There are many literature review I study, but the selected literature review is presented on my screen. Sugandhi et al. Suggest real-time hand gesture detection based on backpropagation neural network. Recognize the 10 different hand movement signals and the descent recognition rate with the proposed model of 80% minimum and maximum 94%, and the average rate was 86.61%. Ashfaq and Khurshid proposed a model for the gesture classification on a data set of utilizing the Grover filter based features, and the major aspects is that the segmentation component of the approach was critical. The system finds the more than 90% accuracy rate for the classification. Mohammed A compares the 4 supervised machine learning in a survey, which are decision tree, k nearest neighbor, artificial neural network, and support vector machine. And he explained how it is tough to identify a particular single classifier than the other with the same accuracy. The learning algorithm performs is heavily influenced by the type of data set. Among all learning methods, the support vector machine performs better than the others. Jadhav et al. Implemented an algorithm for extracting the histogram of gradient orientation HOG features fed into the support vector machine. To build a model, it will classify the test images by the user. The next section is a research methodology. In the research methodology, we introduce and discuss the methods and the algorithms which we want to compare in the study. First, we discuss about the machine learning. The machine learning is a part of artificial intelligence. Learning is a process by which the computer system or any devices can learn from its environment in which he performs some specific task, and then on the basis of the learning, they can improve their performances. The figure shows in the screen. In this screen, suppose a car is an input value. By the using of feature extraction, which convert the raw data into the binary format, and then binary format data is applied to the particular classification model, which classifies the data and provide the output. Supervised learning. Supervised learning is a form of learning mechanism. Learning is classified into the 3 different types of learning: supervised, unsupervised, and reinforcement learning. In the supervised learning, basically work with the training pair. The training pair is nothing but the combination of the input vectors and the output vectors. In the supervised learning, there are 2 types of output value: the target output and the actual output. The target output is also called the desired output. Desired output is that output which we want to produce after the particular operation using our model, and the actual output is that which output we achieve after our operation. In the below figure, a supervised learning is shown where a labeled data with the training data set and desired output by the supervisor is given to the particular algorithm which is implemented for the processing on the system, which classifies the data into the different classes. The first class supervised classifier technique is artificial neural network. The artificial neural network is a highly connected information processing system whose structure and working procedure is inspired from the human brain. In the architecture of artificial neural network, there are mainly 3 kinds of layer: input layer, output layer, and hidden layer. The input layer receives the input signal, and the output layer generates the output signal. All the operations are done in the hidden layer. In the diagram, there is a simple single layer feed forward network. The neural network is classified into single layer feed forward, multi-layer feed forward network. There is single layer feed forward network in which there are only two layers, input layers and output layer. The input layer receives the input signal. The A1 and A2 nodes are the nodes of the input layer which receives the input signal, and the node Y is the node of the output layer which produces the output. Here the W1 and W2 are the weight value which are presented in the synaptic link connected to the both the nodes between both nodes of the both the layer. Support vector machine. Support vector machine is a form of supervised machine learning in which a hyperplane or decision boundary is used to classify the different classes of the data, and when a new data is applied to the support vector machine, he classify the data and predict that the new data belongs to which class 1 or class 2. Here in the figure, the straight line in the center is a hyperplane which separating the different data classes, and the support vectors are those points. Support vectors are those points which are closest to the opponent class. Here the distance between both means that the particular point of one class and the particular closest point to the second class. The difference between this is called margin. Greater margin shows that the greater classification and accurate classification. The next algorithm is a Nav Based Classifier. The Nav Based Classifier is supervised learning which is based on the Bayes theorem. The mathematical implementation of the Nav Based Classifier is shown in below. Here, probability of suppose it is based on the following. There are two events or occur. Here are two events A and B. The probability of event A when the event B is true is equal to probability of event B when A is true into the probability of A division by probability of B. Here the probability of A if the event B is true is also called posterior probability. The probability of event B if the A is true is likelihood probability. The probability of A is called prior probability, and the probability of B is marginal probability. Decision tree algorithm. A decision tree is a tree structured classifier that implemented the divide and conquer approach. In decision tree algorithm, the top level node is called root node and the leaf node presents the result. The root node and the internal nodes are further divided into the branches depends on the particular condition. The major disadvantage of the decision tree is that it performs many numerical operations. That's why it consumes very much memory compared to other algorithms. In the figure, a simple structure of decision tree is shown. Here the root node is divided into the two branches on the particular condition. Two conditions is available, triangle and square, and the particular internal nodes are further divided into the two branches where the condition is straight and rotated. Here the leaf node, which is represented by the particular shaped, give the result. The result and discussion. Here we compare all the machine learning classifier algorithm based on different properties. On the basis of the classification accuracy, we can see that the support vector machine perform better than the 4 other supervised classifier algorithms. According to the comparison table, among all the machine learning classifiers, support vector machine performs best classification process with the highest accuracy rate, followed by the other algorithm. Our study surveyed the 5 distinct classification supervised machine learning algorithms, which is known as commonly used for classifying the and complicated data sets. Here are some references of my presentation. Thank you.
Okay, thank you. So again, this was again review paper all.
Yes, sir. Yes, sir. Yes, sir.
Fine, thank you. Yes, over to you, Pragya, ma'am.
Hello.
Yes,
sir.
ma'am.
Thank you, sir.
All 6 presentation done, ma'am. So
Okay.
prior to this, Mr. Om Sarup, he has given, Om Sarup Thakur from MANIT Bhopal, he has given the presentation.
Okay, okay. So one is Shraddha Soni. Next presenter, Shraddha
It's
Soni.
still,
Are you
it's
there?
still one left.
Yeah,
It's
one
still
left. Shraddha Soni.
Okay, okay.
Shraddha Soni, are you there?
No, ma'am, it's not there in the.
I think she is not there.
Hanji.
So all the presentations are done, sir.
Thank you, ma'am.
Thank you, sir.
Thank you, AKS University.
Thank you. Thank you, sir.
Thank you, Wow, sir.
So
Thank you, sir.
yeah.
Thank you.
Thank you, ma'am. Thank you so much.
So we are going
Yeah, ma'am, actually, I'm not well. I'm suffering from fever, cough, like this. That's why I could not take part in these conversations.
Okay, okay.
But I was listening all the presentations very
Okay.
carefully.
Get well soon, sir.
Thank you. Thank
Take
you.
care, sir.
One, sir, if you give some time to me, only one question I have to ask Mr. Ashutosh. Ashutosh,
Yes, sir. Yes, sir.
why you didn't use that CNN there for the comparison? Because I think CNN is the method which is generally used mostly for this gesture recognition and classification. That's a suggestion.
Yes,
Just go on to that, and because I've seen some paper on this, so I found that the CNN is a better option for that.
Yes, sir. Yeah, sure, sir. I will.
Thank you.
I will do in next time, sir. Yeah, yeah.
Thank you, sir.
Yes. Yeah, yeah.
That's all from my side. Thank you.
Okay. So here we come to the end of our second technical section. Thank you. Thank you all.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am.